where we are with this. Okay, so actually the first thing that I put on your notes, on your handout on 3.6, is just a summary of the inequalities. And I'm not going to run through these. These are just the different things we've already looked at with interval notation and how graphs go and everything. Okay, so I'm going to go down, and what we're going to look at, the first key thing is solving an inequality just by looking at the graph, and that will lead us up to what we're doing. This kind of a thing actually shows up in calculus quite a bit. You do these sign charts like this all the time. So this is an example of a graph, and if we were going to go through and find, for instance, I'll call this function f of x right there. So if I was going to solve f of x is, say, less than or equal to 0, well, actually what that would mean is it would mean where are the function values negative? So that would just mean where is it below? And if you did a sign chart, like we've already learned how to do in the last section, we were doing sign charts. So if it was a less than or equal to problem, then the answer would be, we would just write an interval notation from 0 to 4. Go like that with brackets because of less than or equal to, like that. So that's just saying if that was the situation. If it was greater than, then you would look where it's above the x-axis like that. So this is going to be actually very similar to what I taught you on rational functions in the last section. So to begin with, what I'm going to do, I think on the next page, I've given you a series of graphs, and we're just going to solve the inequality from graphs. You'll see some of this on your homework. It's mostly just stuff that you observe, okay? All right, so with this one, you're going to be doing f of x is less than 0. So that just means identify where the function values are below the x-axis. So I'll just kind of highlight this. So this would be one region there, and then this region here that goes on forever like that. Okay, so if you solve that inequality, you're going to name those things with x values like that. So in set builder notation, we would say set of x, and it would be from -1 to 1. So we would say -1 less than x, less than 1 like that. You have to use less than symbols because that's what the problem said. And then from there, you would say 2 and beyond. So we would say x is greater than 2. So if you write that in set builder, you're just writing it as an inequality like that. Okay. Interval notation, we just say we're going to go from -1 to 1. We don't include those endpoints because it's a less than problem. And then union, then it would be 2 to infinity like that. Okay, so that would be how you would take that graph and write its solution. So if it's less than, you're simply looking at where it's below. If it's greater than, you're looking where it's above. Okay, everybody with me there and how I wrote that? Okay, next one is greater than. So that means we're just going to find all the regions above on this. So I'm going to highlight the regions above. That would be one region, and that would be one region like there, what I've highlighted in yellow. Okay, so we just need to name those intervals. If we do this in set builder notation, we would say you are less than -1, and we'd have to say less than or equal to. Okay, so we would say x less than or equal to -1. Like that. And then the next thing would be between 0 and 1. And I made a little slight mistake on this. That shouldn't be less than or equal to. You know why? It should be less than. Do you know why? What's going on at -1? There's an asymptote, right? And you're not going to be defined there. So that's got to go like that. You have to really pay attention to your inequalities, okay? Even though that was a greater than or equal to, that doesn't really affect necessarily how you write your interval. And then from here, it'd be the same thing. You would be going from 0 to 1, and you got to be real careful on this. You would include the 0 because there is an answer there, okay? That's included, all right? Then you would exclude the 1 because there's an asymptote there. Okay, does that make sense? That's what you get into in these problems. You have to pay really close attention to the inequality. If there's asymptotes, you eliminate that. Okay. Now, if we did interval notation, we would say -infinity to -1. We would not include that because it's an asymptote. Okay, then we would say start at 0, include it, and then go to 1, and don't include it like that. All right, you guys have any question about those details? Does that make sense? Okay, pay attention to the asymptotes when you do this, and pay attention, of course, to the original problem, whether it's greater than or equal to. Okay, because you got to really watch that carefully. Okay, I'm going to let you all go ahead and do these two problems, and just write these out in set builder and interval notation. I think the second one is supposed to be interval notation. So I've given you one that's greater than and one that is less than. Okay, I'll just give you a minute to run through and do that, and we'll see what we did, how we did it. And I'm going to shut off the screen just for a second here. So on these problems, if you just have less than or greater than, it's not as, you don't have to worry as much about the inequality symbols. When you have greater than or equal to, less than or equal to, it's a little bit more involved in what you want to do. All right, so let me show you what I got here. Let's see if we're on the right track here. So the first one is greater than, so you're just looking at where the function is above the x-axis. So I shaded those two regions right there. And if you name this first one, it's between -2 and -1. So I write that as -2 less than x less than -1. And then greater than 3. So 3 and beyond, you go like that. Now you're going to have just a greater than and a less than symbol to write those two things out. These are open intervals on this. It always will be if you don't have the inequality bar underneath. So then it would be -2 to -1, and then 3 to infinity. Okay? Is everybody with me on that okay? All right, okay. The next one is you've got the blue part. This is below. This is a less than symbol, so it'd be below. So it's really from -1 to 2, and don't include those endpoints, so that's -1 to 2, and then 4 and beyond, so it'd be x greater than 4, okay? Your interval would go -1 to 2, open intervals again, and then 4 to infinity like that. So that's how you would name that answer. Yes, do I have something wrong?
Why would it not be negative infinity?
What's that?
The arrow is still below on the left part of the graph, at the very start of the graph.
I didn't even see that, okay. Gosh, I'm blind here, okay. That part 2, right? Okay, sorry about that. Yeah, okay, so let me start this over again. I can't believe I didn't see that. Okay, let me just start over again. Gosh. Okay, so what we would have to say is we'd have to say set of x, and then we would say, this actually we would have to say x is less than -1, like that. That would be this part right here, would be the part that's less than -1. And you have to write that like that. Then what you'd have to do is do this region between -1 and 2 like I did, and you have to break that up separately like this. So you'd have to say -1 less than x less than 2 like that. Then you would have to say 4 and beyond like that. So you'd have to say x is greater than 4 Okay, like that. So that's how you would write that out. And so you can't really write that interval that's going from negative infinity to 2. You can't say like negative infinity is less than x is less than 2. I see students do that some. That's not proper notation. So you have to say x less than 1, x between negative 1 and 2, and then x greater than 4. Okay? When you do an interval now on interval notation, it is actually okay on this to do this basically the same way. So you're going to say negative infinity to negative 1. That'll take care of that part. Then you would say between negative 1 and 2. And then you would say 4 to infinity like that. Okay? Now, the thing on this is that I want to mention is if you said negative infinity to 2, that's not correct because you got to exclude that negative 1 point. Okay, that negative 1 point doesn't count in that particular solution, so you have to break that up. Okay? See, this is kind of real picky about how you write things. So just identify whether you're above or below, and then the key is, can you name the intervals okay? Yeah.
Don't you need another union symbol?
Yeah, right there. Yeah. Actually, union is the correct way to do this. If you do a parenthesis, it's really not incorrect. The preferred notation is a union. Okay? All right? And be sure on my math lab, I've talked to some students in this class about this. Don't use the letter U, use the symbol, or it'll count you wrong. Okay? I think some of you encountered that already. So you be sure to use toolbar. Okay, any question? Anybody need anything to be clarified there? Okay, so that's kind of how you're going to start off, is just by looking at these things graphically. Now we're going to get into how you solve these things algebraically. So a lot of it's going to have to do with a sign chart and graphing out the function. So this is basically what you want to do. We're going to do this without graphing. You can certainly always check these graphically. So you want to make one side 0. This example's got that. Most of the time you're already going to have one side 0. You want to find the zeros. We've learned how to do that. Factoring is something you may have to do. The example we're going to start with is already factored. Then we're going to plot the zeros on a number line, do test points, and then we're going to make a sign chart. Okay? So let's go ahead and let's run through the details on this. So can you tell me in your head, since it's already factored, what are the zeros? Four and negative 3, right. Okay, you can do that in your head. You're just doing x minus 4 equals 0, and then you're doing x plus 3 equals 0. Don't worry about the fact that it's squared. That's the multiplicity. So this would be x equals 4. And then that would be x equals negative 3. You want to just do that in your head when you get your zeros, okay? Now what we're going to do is we're going to do a sign chart, which is very similar to what we did in the last section when we were doing rational functions. So just draw a number line, and then locate these zeros in the right order. So we have negative 3 here, then we have 4 out there. And then we're going to analyze this basically with test points like that, just like we did in the last section. Okay, what I do when I'm teaching this, I kind of box in my test points so that you don't get your interval confused. So let's just use negative 4 as our test point there. Now what you're going to do is plug into the function that I gave you. So we're going to do negative 4 minus 4 times negative 4 plus 3 to the second. All you care about is whether that's positive or negative. So if you do that, that's a negative 8, but it's negative. That's all I care about. This is a negative number squared, so it becomes positive. So what you end up having is a negative times a positive, therefore it's negative. All right, and what that's going to mean is that the graph is below the x-axis right there. Okay, so just evaluate the test point when you do that, and do that in each interval then. Okay, all right, let's see. Test point between negative 3 and 4, it's up to you. I'm going to use 0, okay, and then I'm going to plug in, so I'd have 0 minus 4 times 0 plus 3 squared. Okay, the first parenthesis is a negative number. The second one is a positive. So again, we have a negative times a positive is a negative. So again, we're going to end up being below the x-axis like that. Okay. And then one other step, we need to evaluate bigger than 4. So let's use like 5. Plug in and see what happens. So we'll have 5 minus 4 times 5 plus 3 to the second. Okay, that's going to be a positive there times a positive. So that's a positive. So therefore, that's going to be above. Okay, so just take your test points, plug in after you get the zeros. Okay, everybody with me there okay? All right. Okay, now we can write the answer. So the thing on this is this is a less than problem. So if it's a less than problem, you're really looking at where it turned out to be negative. Okay, so those would be the two things that we're looking at then. All right, and what's going to happen on this is you would end up kind of having to be careful about this. I'm going to write a graph on the number line. Sometimes it's helpful if students do this. So basically what we would have is you would be below 4, but not include 4, and you'd have a little bubble on -3. So your graph on a number line would go like that. So that's worth drawing on your number line like that. You have to exclude the 4, and you have to exclude the -3 because it's a less than problem. If it was less than or equal to, then you would just include all that and write it in one interval. Okay. So what we're typically going to do is we'll just write this one in interval notation. So interval notation, what would you have? You would have everything to the left of -3, so that'd be -infinity, -3. That would be that interval. Then it would be all of the numbers between -3 and 4, not including. Okay, like that. Okay? And then that would be kind of the idea of how you do that. You don't have to graph this or anything. You can certainly check your answers graphically, but you want to know how to analyze this algebraically. And to me, it's kind of an important thing that you're going to do in calculus with these sign charts. You definitely want to learn how to do this way then. Okay? Let's go ahead and let me have you put this in the calculator. I'm not going to do that on every problem, but I want to at least do this on a couple of problems. So what you want to do is just take your calculator out and put in the function. Put in what's on the left side. Let me get everything kind of cleared out of my computer here. And you can just do this in a standard window. So what I'm going to do is just put in parenthesis x minus 4. Okay, then parenthesis x plus 3. And then to the second power, and just do that in a standard window. So I just want you to see visually that it's going to do what the sign chart tells us it's going to do. Okay, so notice it's below, and then the only time it's above is once you get past 4. So that should verify that your answer is correct. Okay, everybody okay? All right, so the sign chart's pretty easy to do. Once you find your zeros, plug in and calculate. All right, everybody with me okay on that? Okay. All right, so let's see. I'll go down to this next one, and when we do this next one, you always got to kind of look at these steps. This is one side 0. You always want that. If it isn't, then you got to make that so. The second thing you got to do is factor this. Okay, so how would you factor the left side? How would you begin the factoring, I should ask? Take an x out. Right, this has a common factor of x. So what you want to do is you want to go ahead and take an x out. Okay, that would leave you x to the second minus 2x minus 3 greater than 0. So you want to start that way, and then this will factor one more time. So you can factor this trinomial. So that would give us x. And then we would have x and x. Looks like 3 and 1. With a minus and plus, and anytime you factor something, just make sure you FOIL it out in your head and make sure it's right. Because if you mess up, it'll mess the whole problem up then. Okay? So that's how you would want to start the problem. Now, can you tell me what the zeros are this time in your head? 0, 3, -1. Okay? You can do all that in your head. You don't have to write anything on your paper. That's x equals 0. X minus 3 is 0. x plus 1 is equal to 0 and solve those equations. So you get 0, 3, and negative 1. Okay, so if it's not in a factored form, that's how you got to start that. Then we're going to go again directly to the, basically to the sign chart then. Okay. All right, so let's go ahead and put together a sign chart. And be sure you put everything in the right order. Okay, we got a 0, we have a negative 1, and then we have a 3, like that. So we got to break it up into actually 4 intervals to analyze this with test points like this. Okay, now you can put your test points in either the original or the factored. I think it's easier if you do the factored form. That's what you'll always see me doing. So we're going to plug into x minus 3x plus 1. Just want to start putting some test points into that and evaluating. So let's use negative 2 here. Okay, and then go ahead and plug that in. So you would have negative 2 times negative 2 minus 3 times negative 2 plus 1, like that. Okay, and again, you can work out and get a numerical answer if you need to, but I just, okay, the negative 2 is negative, the second parenthesis negative, the third parenthesis negative, so what's the result when you multiply 3 negatives? You get a negative. Okay, what does that tell you about the graph, above or below? Below. Okay, good. Okay, so we have that then. Okay, now we're going to take a test point here. Go ahead. You okay? All right. What's the next test point? Like a fraction, okay? Don't worry about it, okay? Just deal with it. You don't even need to use your calculator. So you can just go negative 1/2, anything that fits in that interval. So if you plug it in, you would have negative 1/2, just goes in for x. Then you would have negative 1/2 minus 3, and then negative 1/2 plus 1. You don't have to work out the details. You just figure out if each parenthesis is negative or positive. You can always pretty much do that in your head, see. So you'd have a negative there. Negative 1/2 minus 3 is also negative, but negative 1/2 plus 1 is a positive number. So what's the result here? Positive. So you have two negatives make the positive. Positive times positive's positive. So that's going to mean that you are above the x-axis, like that, okay? And then we just proceed from here, okay? So I'm going to go ahead and put in a 1 there. That's a good test point. Again, plug into your function. So we would have 1 times 1 minus 3 times 1 plus 1. And that looks like that's a positive times a negative times a positive. So what's that? That's, are you sure? Negative, okay. Positive times positive, positive. Positive times negative is negative, right? Okay, so you got that. Be careful on your signs. And then that's going to be below. And these things alternate frequently, not always though, so don't expect them to always alternate. And then finally the last one, I'll put in like 4 as my test point. So I'll have 4 times 4 minus 3 times 4 plus 1. That'll give a positive times a positive times a positive. So that's going to give you a positive result, meaning that you are above the x-axis. Okay, so that's kind of what's going to go on this problem, is you'll end up having something that looks like that then. Okay, all right. Now, I want to show you something on this before I write the solution. But technically, really what's happening on this is the graph is going to kind of do something kind of like this. If you think about the graph, it's going to be below, then above, like this. It's going to do kind of what we would expect from a cubic function. So it's going to do that. It's going to have the endpoint behavior we'd expect it to have. So now what we need to do is, this is a greater than problem. So what are you looking for in your sign chart? You're looking for where it's above the x-axis, okay? So I usually, when I'm teaching this, like to kind of just draw out a picture on this. You can use a bubble, or you can use a parenthesis. It doesn't matter. Sometimes I like to just use bubbles on these. So those are all bubbles. You're going to be between these two numbers, and you're going to be past 3 like that. Most of the time, you're just going to write these in interval notation. So interval notation, you would say from -1 to 0 And then the second part would be 3 to infinity. So that would be the answer of the problem. And you could graph this on the calculator, and that would verify kind of the rough sketch of the graph that I had. Okay? Does everybody understand what I'm doing on the test on the sign chart? Okay, so you're going to do this a lot on these problems, and like I said, you'll do this a lot in calculus. It'll be a real frequent thing that you'll do all the time, so you want to get this down pat in this class and understand the graphical relationship that exists on that then. Okay, any questions about anything? Okay, so let's see. On the next page, I'm going to start you off on this and then give you a chance to finish this. All right, so let's just kind of do the first part together. I'm going to have you do the sign chart together. Okay, what would be the first step on example 4? One side is equal to 0, right? So you probably would want to move that. I always recommend that you get 0 on the right side. That's my recommendation, that you do it that way. So this would end up being x to the 4th minus 9x to the 2nd less than or equal to 0. Okay, how do you factor that? Take an x squared out. It's got a common factor of x squared. So you want to go ahead and take x squared out. So that would be x squared minus 9, like that. Can you factor x squared minus 9? Yeah, x plus 3, x minus 3. That's the difference of two squares. Okay, so we have x squared times x plus 3, x minus 3 less than or equal to 0. All right, so you're going to have 3 zeros. So I want you guys to go ahead and finish the problem from here. Okay, just get the factoring down and then take it from there. You got 3 zeros, and build that sign chart. Do your test points. I'll give you a couple minutes to see if you can put this one together okay. And again, the zeros, most times just do it in your head. You can do that in your head. So again, your zeros would be 0, negative 3, and 3. So you want to make sure you get that put together like this. So I'll put a negative 3 there, 0 here, and a 3 here. And then what happens on this is when you start putting in test points, this is kind of what I do. Now, you can do this. If you square something, isn't that always, that part right there always going to be positive? Okay, so see, you can use that. You can take advantage that that part right there is always positive, regardless of what your test point is, because you're squaring that, okay? And then the next one, you can plug in test point here, and that would be negative 4 plus 3, and then negative 4 minus 3. So what you'd end up having is a positive times a negative times a negative, so you should have got a positive there below, meaning above the x-axis, okay, like that, okay? Test point here, it's up to you. I'll use negative 1. So the first one is positive when you square that. Then you would have negative 1 plus 3, negative 1 minus 3. So that will be positive times negative, which ends up being negative. Okay, so that takes you below the x-axis. I'll use a 1 here. Same thing will happen. So let's see, I got a positive, and then I have 1 plus 3, 1 minus 3, so it'll be positive times negative. So again, it's negative like that. That's what you should have got. And then the last one, I'll put like a 4 as my test point. So I would have 4 plus 3, 4 minus 3, like that. So it's all positives. So you'd have a positive answer, so that would mean you're above the x-axis. So that's what you should have if you've done the analysis of your sign chart. I think we're doing that okay. And what I'm going to do on this is just kind of draw a number line. And remember, everything's included on this. So the negative 3 is included, the 3 is included, even the 0 is. So actually, it's just the whole thing. So you don't have to break it up into 2 intervals. I think some of you were going like -3, 0, union 0, 3. That's not necessary, is it? Okay, you put the whole thing together, so it's just from -3 to 3 is what you should have. Okay, so just put it together like that in an interval notation. Now, on the graphing calculator, I'm just going to show you what it's going to look like. So again, if you want to look at your graph, you're going to see that you're below the x-axis from -3 to 3. So that would verify that you've got that answer right. So do that when you're doing homework and stuff. You got a little time, just double check everything. Okay, it's easy to do that. Okay, any questions with that? Are we doing okay? Looks like we did the sign chart okay, so that's important. So the next thing we do is we do rational inequalities, and it's going to be almost the same idea. You're going to make sign charts, but you get into asymptotes and stuff like that. So when you're doing a rational inequality, and that's when you have a fraction, again, right side needs to be 0. You're going to find the x-intercepts. That's real important. You find the x-intercepts, and you're going to find vertical asymptotes. Okay, and then you're going to do the sign chart and choose test points. So one thing is your sign chart. I thought I wrote this down, but maybe I did. The sign chart, what you're always going to use is x-intercepts, and you're going to do vertical asymptotes. Those are the two things that you got to use, okay? So the last problems, we just use zeros. On rational functions, you got to use these numbers, okay? So we're going to do that. You have to kind of really watch the signs on this. A lot of times what students sometimes mess up most on these problems is the sign, not paying attention to whether there's a parenthesis or a bracket. Okay, so if we look at this problem right here, this one is, you already got one side equals 0. So what we're going to do is just find two things. Okay, the vertical asymptote. How do you find a vertical asymptote on a rational function? What are you looking at? You're looking at the denominator, right? What are you looking for in that denominator? What makes it equal to what? 0, okay, undefined. Okay, so when you look at your vertical asymptote, you want to look at x plus 3 equals 0. Okay, well, that would be x equals -3, so that's where you have a vertical asymptote. Okay, now you can, when you do an x-intercept, you know that you always just set, the function equal to 0. Okay, so what we would do is the function is x minus 3, x plus 3 equals 0. And then you solve that equation. Well, you can bypass doing this because if you solve this equation, all you're going to really do is multiply both sides by x plus 3 anyway. So it's okay if you set the numerator equal to 0. Okay, so if you do that, you'll get your x-intercept. So we have x minus 3 is 0. Therefore, x equals 3 is your x-intercept. Okay, so when you're doing these problems, that's what you want to look for. Look for a vertical asymptote and look for an x-intercept if you have one. Okay, you don't necessarily even have to have one depending on what the function is. Okay, so what I'm going to do is we're going to go ahead and develop our sign chart here. So we're interested at -3 and we're interested at 3. Okay. Now what I do on this, sometimes this is a good thing to do, just kind of put a bunch of U's. That just means I know I'm undefined there. And if I'm undefined, that means in my solution, that would have to be open, okay? Once we kind of analyze the sign chart, that -3 is going to be open in this problem, okay? The other thing is, this is an x-intercept. Okay, and since this is a less than or equal to problem, that's going to mean that that is going to be solid. Okay, the place where students mess up a lot of times on these problems is the vertical asymptote. You have to be open on that interval when you do that. And then from here, it's simply a matter of taking the function, x minus 3, x plus 3, and plugging in test points. So let's start with -4 and plug into the rational function. So that would be -4 minus 3 over -4 plus 3. Okay, you have a negative numerator, you have a negative denominator, so what's the result? Positive. You're dividing two negatives. So you end up with a positive. That would tell you that you're above the x-axis there. Okay? Move on into the next interval. Let's use like a 0. Okay, plug that into the function. So that would be 0 minus 3 over 0 plus 3. That's a negative numerator, positive denominator, so that's negative. That means that you are below the x-axis like that. Okay, and then finish it up with a test point bigger than 3, say like a 4. Then you would have 4 minus 3 over 4 plus 3. That would be a positive numerator, a positive denominator, so it's positive. Therefore, we would be above. Okay, so it's always just using test points and evaluating whether the function's above or below the x-axis. So what are we looking for in this problem? Above or below? Below, okay, because it's a less than or equal to means we're looking at below. So that would mean that this happens in this interval right here. That would be the interval that you name. All right, so what you would have on this is interval notation. You would have a parenthesis on the negative 3 because that's open, and then you would have a bracket on the 3 like that. Okay, you have to be really careful about brackets or parentheses on these problems. So that's the idea on the problem. If you graph that in your calculator, you should end up seeing this kind of thing like this. And I'm going to go ahead and graph this one on the calculator. You can do it in your calculator if you want to go ahead and do this. So the way you put this in your calculator is you do x minus 3 divided by x plus 3. And just visually, you should be able to see that the sign chart will verify this. Okay, you're going to have a region where you're above, a region where you're below, and then you're back above again like that. Okay, and you do have that asymptote there. You can tell that there's a vertical asymptote there because of that break in the graph. Okay, all right, any questions about what we did? All right, just be real careful about the bubble on that one. You got an asymptote, that's why that has to be a parenthesis. Okay, all right, so let's see. We're got the last page on here. I'm going to do a couple of more here to wrap us up here. So on example 6, what you'd need to do on this, first of all, one side is 0, so you have that. Okay, then what we have is you got to factor the bottom, so the numerator's already factored, so you would have x plus 6 squared, and then the denominator is a difference of 2 squares, so that would be x plus 2, x minus 2. Okay, greater than or equal to 0. Okay, so you got to find two things. You got to find x-intercepts, and then you got to find vertical asymptotes. All right, how do you find the vertical asymptotes on this problem? What do you look at? Denominator. You look and see what makes the denominator equal to 0. Okay, how many vertical asymptotes do I have? I have 2. They are x equals negative 2 and x equals 2. Okay, so we have 2 vertical asymptotes on the problem. Okay, what do I need to do to find an x-intercept? Set the numerator equal to 0, right? Okay. And really, the only thing that matters is the x plus 6. You don't have to have the square. I mean, you could put it there, but if you do that, all you'd do is square root of both sides anyway. So you get x plus 6 equals 0. Therefore, you have an x-intercept at x equals negative 6. Okay, once you get this factored, then you can figure those two parts out pretty easily in your head. Okay. So those are the 3 things that we're going to use in our sign chart. You always want to use x-intercepts and vertical asymptotes, nothing else. So let's see. It looks like what we have is we have negative 6. And let's see, that's an x-intercept. Okay, I have x equals negative 2. Now I'm going to put a u to stand for undefined. That's just kind of the way I like to get students to do that, so you're paying attention to that. So that's a vertical asymptote. You also have a vertical asymptote at 2, so you're undefined there too. All right. So now what we want to do on this has got an equal to bar, right? So where would be the open bubbles on this?
Yes.
At the vertical asymptotes, right? That's why I put the U so it's real loud and you won't make that mistake. You know those are open. How about the X-Intercept? Is the X-Intercept closed or open? It's closed because it's defined. Okay, you are defined at the X-Intercept. Okay, so you want to make sure you get that put together. Okay, now what we're going to do is we're going to do all of our test points. And let's just do something like -7 here. Now what I would do is I would work with this part right here that I'm highlighting in blue. Okay, let's go in there. Now the way I would do this is the numerator is something squared, right? So what's going to happen on that numerator no matter what you plug in for your test point? You're going to get a positive. Okay, if you don't see that, it's okay. But the idea is that numerator will always be positive. It just saves you a little bit of time anytime that shows up. So you don't have to waste your time doing that. Now what's really going to matter is the denominator. So on the denominator, you would do -7 plus 2 and -7 minus 2. Okay, just plugging in there. So you would have a positive over a negative times a negative. So that's what? That's a positive. So that would mean that you are above the x-axis. Okay, so that's what that is. That would be one of the solutions we're looking for too. Okay, test point here, let's use something like -3. Plug into the denominator, you'd have -3 plus 2, -3 minus 2, so that's a positive over a negative times a negative, same result, right? Okay, so that's still going to be positive, so that means you're above the x-axis. So you'll have that as a part of your solution also. Okay, I'm going to use 0 here. So if I plug into the denominator, I'll have 0 plus 2, 0 minus 2. So I'd have a positive numerator, and then a positive times a negative there. So that's going to be positive over negative. That's equal to a negative. Therefore, you're going to be below the x-axis on that region right there. Okay? And then last, let's use a number bigger than 2, like 3. Again, plug that in. I have 3 plus 2, 3 minus 2. So that's plus over plus times plus. That's a plus. So that would also be above like that. Okay? So that's a sign chart. Yeah.
So I got all of this as well, but in the calculator, it shows -6 to -2 as below.
Can I see how you put that in, just to make sure? Okay, that because it doesn't make sense with my arithmetic. Actually, that is the part right there. You're talking about below -6, right?
Mm-hmm.
You can't really see on that too good. If you did, like if we made the y go -1 to 1 like that, then you might be able to see. See how it's above there?
Yeah, but to -2, like -6 to -2.
-6 to -2, okay, it's above. Okay, right there. So it looks like it's above and then above. And then it's, I'm out of range, so you're not seeing the below part. What I did is I zoomed in on it, because the way your graph is, you really can't see what's happening too well. So trust the math, okay? All right? But sometimes you have to do that. You have to kind of zoom in on those a little bit. Okay, well, am I looking for above or below on this problem? What?
Above.
Above, yeah, it's greater than, okay? So since it's greater than, you're looking for above. So again, I'll just take my orange pen here and highlight that. So you would be here, and you would also be here, and you would also be there, okay? And you have to be real careful about how you write your intervals in, okay? So could you put this in one interval? Would that be okay to go one interval like that? Or do I need to break it up into two? Now it is a greater than or equal to, so we have to exclude that, but we can include that, so you can just do one whole interval there, Okay, it's okay to have one whole interval because of that. If the -6 was a bubble, you'd have to break it up into 2. So what we'd have then is we would just say -infinity to -2 with a parenthesis, like that, and then it would be 2 and beyond, like that. Okay, so that would be the answer to that problem. Yes. Say that again. You could. I wouldn't count a student off for that. It's just unnecessary. So if you had like -infinity, -6 bracket. Oh, set builder. Yeah, I'm just using interval. If you did set builder, you would say set of x. You would say, and if you do that, you have to break it up into 2 because you can't say -infinity to -2. So you would have to say actually x is less than or equal to -6, or then you'd have to say -6 is less than or equal to x less than 2, and then you would have to say x greater than 2. Now that's how you'd have to do that in set builder notation. You can't just say -infinity is less than or equal to x less than 2. That's not proper notation. So you'd have to say less than or equal to 6, and you'd have to see between -6 and 2, including and not including, because of the bubble and so forth. Okay? Okay, so let's do this next problem. Let's go ahead and do that, and then we'll take a break here after I do the next problem. Any questions about what I just did? Okay, so it's all the same idea. All right, so let's do this one. This one's got a little bit more algebra. So what's the first thing you have to do on example 7? You're going to get one side equal to 0, okay? So you want to go ahead and slide that over. I always like to get the right side with the 0. So we'd have 5 over x minus 3 minus 3 over x plus 1 is greater than 0. Now you can't do test points and stuff until you combine this fraction by getting a common denominator. So you have to do that. So the common denominator is both of these things put together. So that means this first fraction has to be multiplied by x plus 1 over x plus 1. You always have to multiply the top and bottom by the same thing to introduce that common denominator. Okay, what do you need to do to the other fraction?
Yeah, to add
x minus 3, exactly. Okay, just kind of squeeze in the x minus 3 like that. So now they have a common denominator, see? Okay, all right, so I'm going to write a couple of steps on this. I'm going to distribute here, and when I distribute, that's going to be 5x plus 5 all over x minus 3 times x plus 1, like that. I'm going to bring down the minus. This is a place you got to really watch yourself on. Then I'm going to distribute. I'm going to use 3, not -3, so I'm going to go 3x minus 9 over x plus 1, x minus 3 like that, greater than 0. Okay, then you're going to combine that into one fraction and be real careful about that negative. So that's going to actually change those signs when you put that together. I'm just bringing down the minus, and I'm going to change the signs now. So when I put this all together, the numerator will be x plus 5 minus 3x plus 9. That minus distributes through changing the sign. And then you would have this all over x minus 3 times x plus 1, and that's greater than 0. Okay, be really, really careful when you have that. If you're not paying attention to that, you'll slip up on a sign somewhere. Okay? Okay, now I've got like terms, so I've got the x's go together and then the numbers go together. So 5x minus 3x is 2x, and 9 plus 5 is 14. Then I have x minus 3 times x plus 1, and then that's greater than 0 like that. Okay? Now I'm ready to roll with this. You could factor out a 2 out of the top if you wanted to. I think I'll go ahead and just let's factor a 2 out of the top. So you'd have 2 times x plus 7 all over x minus 3 times x plus 1 greater than 0. Okay, so when you do these problems, you have to do some algebra to get that thing set up for your sign chart. So you have to do that. Okay? Now, what we're going to do here is, that's kind of the first step is doing that. Second step is let's find the vertical asymptote. So look at what we have. You should be able to do that in your head. Can you tell me what the vertical asymptotes are? 3 and -1, right. That comes from here. Okay, you can do that in your head. You're just solving the equation, setting the denominator equal to 0. So that would be x equals 3, x equals -1. Okay, so that's where your two vertical asymptotes are. And what do you do to find the x-intercept? Set the numerator equal to 0. Okay, so the numerator is 2 times x plus 7 equals 0. Well, you can do that in your head. Okay, that would be x equals -7. So you've got now, those are going to be the 3 numbers you're going to use on your sign chart, is your 2 asymptotes, and then you're going to do your x-intercept. Okay, and then from here, we're ready to go ahead and put together the sign chart. Make sure you have everything in order. So x equals -7 is an x-intercept. And then -1 is a vertical asymptote. So I'm going to write that like that. And let's see, 3 is also a vertical asymptote like that. Okay, now I'm going to go ahead. I always like to kind of figure out the bubble thing before I finish stuff up. What are you going to have on this one? Bubbles or solid or what? All bubbles, exactly. Yeah, they're all bubbles. Okay, so vertical asymptotes have to be bubbles, but also this is a greater than problem anyway. So everything's a bubble when you do that. Okay, so that's going to go like that. And then we just need to evaluate the situation with test points. Okay, so let's go ahead and do that then. Okay, I think what I'm going to do on this is I'm going to do this. You can actually, I want you to know how to do a sign chart manually, but I want to show you that, you can actually do a sign chart with a graphing calculator. So I'm going to show you how to do that. Now I'm going to go back to, just putting in the answer we have. So I'm going to put 2 parentheses, x plus 7. If you're going to put it in, you have to have that. Whoops, I put the wrong thing in there, I think. So it's got to go like this. Now you can multiply that out. I'm just going to go 2x plus 14. The calculator doesn't care if that's in a factored form or not. And then the denominator, I got to have a big set of parentheses and then parentheses inside that. So I would have x minus 3. And then I would have x plus 1. Okay, like that. So I'm going to show you that the graphing calculator will give you the sign chart anyway. Just kind of show you a quick way to do this. Okay, so I'm going to do a zoom 6, and you can trace your test points like this if you want to. So if you're on your homework, if you're kind of in a rush, although I don't know, sometimes it takes just as much time to put stuff in your graphing calculator anyway. So what you can do is you can trace out your test points if you want to, or you can just observe the graph. So like if you used a test point of -8 here, so if you trace it -8, you would have a negative number. When you were asking me about that graph a minute ago, you could have just used a trace on that interval to see if it was negative or positive instead of readjusting the window too. That's another way to do that. Okay, and then by looking at this, you're going to have a plus here because you're above. You're going to have a negative there because you're below, and a plus there. Okay, so you can actually, once you graph it, you're kind of like doing 2 things at once. You're checking your answer almost, and then you're kind of filling out your sign chart like that. Okay, so you could actually use your graphing calculator and use technology to use a sign chart. When I teach calculus, I show students that a lot, that you can actually do that. Okay, so what are we looking for in this problem? Since it's greater than, what are we looking for? Where it's plus or where it's above. So that would end up just being like this. We would be from there to there and from there forever. Okay, so that would be your solution. So in interval notation, we would just say parenthesis -7, -1 parenthesis, union, and then 3 to infinity like that. Okay, and that's how you do that. Okay, so I think you, just based on watching you guys do a problem a minute ago, seems like you're doing your sign chart okay. So once you get that down, then you'll probably be fine. This problem right here is the one that takes the most work because you have to algebraically simplify that before you can even go to your sign chart. Okay, any questions about what we did? Okay, so let's go ahead and take a 5-minute break, and that'll wrap up this section, and then we'll start on the 4-1 and do that second half of class.